Welcome to Mastering AWS Step Functions, presented by AWS Hero. The first question is, what is Step Function? AWS Step Functions is a serverless orchestration service that lets you integrate with AWS Lambda functions and other services in AWS to build business-critical applications. Through Step Functions graphical console, you can see your application's workflow as a series of event-driven steps. Step Functions is based on state machines and tasks. A state machine is a workflow, and a task is a state in a workflow that represents a single unit of work that another AWS service performs, and each step in a workflow is a state. With Step Functions built-in controls, you examine the state of each step in your workflow to make sure that your application runs in order and as expected. Depending on your use case, you can have Step Functions to call AWS services such as Lambda to perform tasks. You can create workflows that process and publish machine learning models. You can have Step Functions control AWS services such as AWS Glue to create ETL workflows, extract, transform, and load workflows. You also can create long-running automated workflows for applications that require human interaction. To call other AWS services, you can use Step Functions SDK integration, or you can use one of Step Functions optimized integration. The AWS SDK integrations let you call any of over 200 AWS services directly from your state machine, and that gives you access to over 9,000 API actions. Step Functions optimized integrations have been customized to simplify usage in your state machine. Step Functions has two workflow types, the standard workflows and the express workflow. The standard workflows have exactly once execution, so it has once workflow execution and can run for up to 1 year. This means that each step in a standard workflow will execute exactly once, while the express overflow or the express workflows, however, have at least once workflow execution and can run up to 5 minutes. This means that one or more steps in an express workflow can potentially run more than once, while each step in the workflow executes at least once. Executions are instances where you run your workflow to perform tasks. Standard workflows are ideal for long-running, auditable workflows as they show execution history and visual debugging. Express workflows are ideal for high event rate workloads such as streaming data processing and Internet of Things data ingestion. The specifications of the standard workflow are as follows. It has 2000 per second execution rate. It has 4000 per second state transition rate. It is priced by state transition, and it shows execution history and visual debugging, and it supports all service integrations and patterns. While express workflows have the following specifications. They have 100,000 per second execution rate, they are nearly unlimited state transition rate, or they have nearly unlimited state transition rate, and they are priced by the number and duration of executions, and they send execution history to Amazon CloudWatch, and they show execution history and visual debugging based on the log level enabled. Finally, they support all service integrations and most patterns. So what are the use cases where we can use step function? Step functions manage your application's components and logic so you can write less code and focus on building and updating your application quickly. Here we describe the typical use cases for working with step functions. The first use case is function orchestration. You can create a workflow that runs a group of Lambda functions or steps in a specific order. So one step or one Lambda function's output would pass to the next Lambda function, and you can see that the last step in your workflow would give the result. With step functions, you can see how each step in your workflow interacts with one another, so you can make sure that each step performs its intended function. The second use case is about branching. Here we have a customer that requests a credit limit increase, for example. So using a choice state, you can have step functions to make decisions based on this choice state's input. So if the request is more than your customer's pre-approved credit limit, then you can have a step function to send your customer's request to a manager for sign-off, and if the request is less than your customer's pre-approved credit limit, then you can have a step function to approve the request automatically. Use case number 3, error handling. In error handling, we have retry and catch block. In retry, in this use case, a customer requests a username. So the first time your customer's request is unsuccessful, we use a retry statement. Then we can have a step function to try your customer's request again. The second time your customer's request is successful. In the catch block, in a similar use case, a customer requests an unavailable username. By using a catch statement, you have step functions to suggest an available username for you. And if your customer takes the available username, you can have a step function to go to the next step in your workflow. And that next step is to send a confirmation email, for example. If your customer doesn't take the available username, then you have your step function to go to a different step in the workflow, and that is to start, for example, the sign-up process over again. Use case number 4, human in the loop. In this scenario, a customer needs more money or needs to send more money to a friend. Using a banking app, one of your customers sends money to a friend. Your customer waits for a confirmation email with a callback and a task token. You have step function to tell Lambda to send your customer's money and report back when your customer's friend receives it. After Lambda reported back that your customer's friend receives the money, you can have your step function to go to the next step in your workflow, which is to send your customer a confirmation email. Use case number 5, parallel processing. Here a customer wants to convert a video file into 5 different display resolutions so the viewer can watch the video on multiple devices. By using a parallel state, the step functions input the video file so Lambda can process it into the 5 display resolutions at the same time. Use case number 6, dynamic parallelism. In this use case, we have a customer that orders 3 items, and you need to prepare each item for delivery. So you check each item's availability, then you gather each item, and then you package each item for delivery. By using a map state, step functions has Lambda process each of your customer's items in parallel. So once all of your customers items are packaged for delivery, step functions go to the next step in your workflow, and that step would be to send your customer a confirmation email with tracking information. Service integration. Step functions integrates with multiple services in AWS. To combine step functions with these services, we can use the following service integration pattern. Either the request response pattern, which is the default, and this is supported by Express Workflow and the only option in Express Workflow. And here we call a service and we let step functions to progress to the next state after it gets an HTTP response. The second pattern is to run a job. We see here the name of the function .sync. In this pattern, we call a service and we have a step function to wait for a job to complete. The third pattern is to wait for a callback with a task token. Wait for task token. In this pattern, we call a service with a task token and we have a step function to wait until the task token returns with a callback. Standard workflows and Express workflows support the same integrations, but they do not support the same pattern, the same integration pattern. Express workflows do not support the run a job or the wait for callback pattern. Optimized integration pattern support is different for each integration. In this lesson, we learned what step functions are, how they are integrated with other services via the software development kit, the SDK, or via optimized integrations. Then we learned about the two types of workflows, the standard and the express workflow type. After that, we looked at some of the typical use cases for step functions. Finally, we covered the three integration patterns: request a response pattern, run a job pattern, and the wait for a callback with a task token pattern. In the next lesson, we will cover what are the requirements before we start using step function. To check my next lesson, please do not forget to subscribe and share your comments so that you encourage me to upload new videos. Thank you very much.